DSC Marine Radio to DSC Marine Radio. The marine environment is an open space environment with little or no obstacles, high water vapor densities, mean temperatures of 27 degrees Celsius, and thermal noise, assuming no other radio devices or electric motors. It is prone to rapidly changing weather conditions, and the effective line of sight is limited by antenna height due to the Earth's curvature. The marine environment's features, as stated above, can cause changes in refractive index, attenuation, reflection, and refraction. These effects can wreak havoc on a communication signal's quality, capacity, and ultimately the communication link length. The two most applicable models are the ITU-R P1546 and the Longley-Rice propagation model. They both account for reflection, refraction, diffraction, scattering, and Earth's curvature in their mathematical modeling. The ITU model is for point-to-area predictions, while the Longley-Rice model is only applicable for point-to-point communication. The ITU-R is also an effective model as its antenna height is kept within a range of 3,000 meters and still allows for an effective communication range between 1 to 1,000 kilometers. The ITU-R propagation curves take into account the refractivity of the air in tropical climates such as Mayaro, while free space path loss only takes into account attenuation through free space. These models account for other fundamental limits such as terrain and climate that are also factors for attenuation and signal decay. Our model of choice is the ITU-R P1546 for these instances stated above. The link budget is an allocation of power resources. Using this, various limiting factors and the quantity and quality requirements, the maximum link length can be determined. Free space path loss. By transposing the link budget equation, the free space path loss was determined based on the knowledge of the antenna gains, receiver sensitivity, and frequency. By substituting their values and transposing the free space path loss equation, the maximum distance was found. However, by utilizing the SNR and calculating channel noise, a new received power is found. This value is substituted in free space path loss equation to evaluate a distance of 9,708.54 kilometers. The maximum link length, however, was found based on the most limiting factor, antenna height. By utilizing this equation, the maximum link length is found due to the Earth's curvature and antenna height. To ensure the distance still ensured an SNR capable of discerning information at the receiver, a new SNR value was calculated as shown below, where the free space path loss now incorporates the new distance and the new received power found. By utilizing the equation, SNR is equal to received power minus channel noise, the new SNR was found. These are the results from the theoretical analysis. This is the result from the simulation conducted, as well as the figure produced from the simulation. It can be seen here that there are small discrepancies in calculated values between the two. The DSC Marine Radio can be applicable for receiving weather forecasts and navigational warnings, and for distress assistance. To increase the transmitting distance, by analysis of the link budget, the transmit power can be increased or the receiver sensitivity. However, it would be best to increase the antenna height to ensure longer communication ranges. The technology is able to combat absorption and climate conditions. Thus, you can use DSC Marine Radio in marine conditions since it is not attenuated quickly. Also, because of its small bandwidth, it is not affected by noise greatly. The difference in theoretical and simulation results. The calculations are done under the free space path loss for line-of-sight propagation. However, radio mobile software utilizes the ITM, which is based upon the Longley-Rice model. Important here is the fact that refraction and reflection is considered in the software. Due to the short antenna height, the refraction index is high, and thus radio waves move slowly across closer to the Earth, causing a slight bending of the waves toward the Earth. This is what is taken into consideration in the simulation. Here, we now consider some factors in designing the link. Some are the application to be designed and the Earth's curvature and antenna height.